Hi everybody, I just wanted to make a little video to review some of our geometry concepts that should be helpful for us for tasks 6.5, 6.6, and 6.7, and actually a little bit of Module 7 too. One of the topics that we're going to be covering is polygons. If you can't remember what a polygon is, it's a two-dimensional closed figure with at least 3 sides. All of these are going to be examples of polygons. Specifically, you're going to notice this purple one that kind of looks like a cross. That one has 12 sides on there. We would just call that a 12gon. This one, most of you guys can probably tell it's a rectangle, but that's a 4-sided polygon. This one, we've got an octagon. It's got 8 sides. This one we would call a pentagon with 5 sides. Here, this looks like a trapezoid, but it would be a 4-sided polygon. The triangle has 3 sides, and then this one is also an octagon because of 8 sides. You might notice I called this one an octagon, and I also called this one over here an octagon. This one looks more like what we're used to seeing. It looks more like a stop sign. That's actually a regular octagon. If you have a regular polygon, it means that all the sides are the same length and all the angles inside the figure are going to be congruent. But that's a special type of polygon. So that's a regular, specifically a regular polygon or a regular octagon in that case. And then this one would just be an octagon. The sides are different lengths on there and the angles would be different measures too. These are not polygons. You might notice the heart and the circle break the part of the definition that says that the figure has to have straight lines or straight sides. And then part of the other definition that's broken up from this one is that the figure has to be closed. This figure is not closed because it's got this open side. If you were to think about being closed like being a fence, closed-in fence, this one breaks that. And then also it really only has 2 sides on there. So those 3 are not polygons. Here we got a bunch of quadrilaterals. So quadrilaterals are polygons that have 4 sides. There's a whole lot of different types. If I could just start by talking about this one in beige that's got the arrows. Those 2 arrows are showing that there's a set of parallel lines. So this side is parallel to this side. Notice that the other 2 sides are not going to be parallel and they do not have to be the same length just to be a trapezoid. But if those 2 sides that are not parallel, if they do happen to be the same length, then they would be marked congruent, like in this figure. And then we call it a isosceles trapezoid. Keeping in mind, like if you had an isosceles triangle, it means the 2 sides are the same length. If you have an isosceles trapezoid, it means the 2 sides are the same length. And then next, if we were to look at this figure, you're going to notice those arrows coming up again. So one set of sides is parallel, and then the other set of sides is parallel. We call that a parallelogram. If you happen to have both sides, or 2 sets of sides that are parallel, and then also 2 sets of sides that are congruent with right angles, we will call that a rectangle. So notice with the rectangle, even though it's not marked, these 2 sides would be parallel, and then the other 2 sides would be parallel, but then you also have 2 sides congruent with right angles. And then if you were to take that but have all of the sides congruent, then it would be a square. So notice the square has 4 right angles, 4 congruent sides, and then 2 sets of parallel lines on that, so that's our square. If you were just to have the 2 sets of sides congruent, but without right angles, then we call that a rhombus. So a rhombus just has 4 sides congruent. And then taking a look at this other figure where we have 2 pairs of congruent sides, we call that a kite. So notice AB is congruent to BC, and then AD is congruent to CD, but there's no right angles. So we call that one a kite. And then another thing that I wanted to mention was symmetry. So a figure will be symmetrical if it's identical after doing a reflection. And then another type of symmetry that we're going to look at is going to be called rotational symmetry. So that would be if a figure, it can be symmetric with a rotation. Just in the video, we were going to talk about figures that are symmetric over a specific line, which would be the symmetry that goes over reflection. So these are going to be symmetric over the x-axis. You kind of notice if you were to fold it over, the one part of the graph would land on the other part of the graph. And then the circle, same thing. If you reflected over the x-axis, those 2 parts would be identical. These 3 are going to be symmetric over the y-axis. So again, you can kind of see if you're folding over, but now over the y-axis, the one half of the figure would land like on top of the other half of the figure. And then these are the figures that have symmetry, so I drew in the line that you could be kind of folding over, reflecting over to get the, to match up or to be identical. So the heart would just be kind of cut right down the middle to make it symmetric. And then you might notice this one looks like a rectangle. When we think about folding a paper that's a rectangle, you think about like hot dog or hamburger way. So both of those are shown on there that you could do it either hot dog or hamburger way. This one must be an isosceles trapezoid because if you can fold it over, it must mean that those two sides are congruent on there. So then it's shown with that line of symmetry. This must be a square because of all those lines of symmetry on there. So a whole bunch of different ways. I kind of think about the different ways you could cut like a grilled cheese sandwich or peanut butter and jelly sandwich or something. A whole lot of different ways that you could cut it. The little girl up here, she can be cut in half and she's symmetrical. This must be an equilateral triangle. It's got several different lines of reflection on there that you could fold it. And then this one we got the hexagon. Same thing, it's got quite a few different lines that you could fold over for symmetry. And then you might notice this one looks just like a parallelogram. They're showing that it does not have any lines of symmetry. Anyway, I hope that was a good review for you guys with quadrilaterals, polygons, and symmetry. Thanks for listening.